there, Okuma fans. Charlie with the Gossaker Application staff. We're back for episode 4 of the Advanced One-Touch Programming Assist software that is on our Okuma Turning Centers. In episode 1, we configured the software so that we would have default feeds and speeds for recommended materials, some parameters on the machine and the way we like to do things. Then we jumped into creating tools for the next installation in the series. Created a bunch of tools for this exact part, and again, those tools will be in the machine forever, so once I create them, I'm done. Then in the third installment, we created this little file right here called class PET, and that was our material, our work holding, are we using both spindles, all of the information regarding this exact part. So now we are ready to use the actual programming software. We're going to do some fancy stuff, but the real Easter egg in this episode is we are going to use the automatic feature recognition for Advanced One-Touch so that this all the fruits of our labor in the past 3 episodes will come to fruition here. Our part that I may have shown you earlier, whoa, hey, how did that happen? Shoop, there it is. Pretty simple part. We're just doing turning. We will do some milling in a future installment, but right now we're just going to worry about making this part. And my strategy, I would like to do the bulk of the work on the main spindle, drill all the way through, then come grab it with the sub spindle and face and chamfer the back side of this. So I created a 2-dimensional DXF file of that part. And there you see it in my AD0 right there. I don't need it right now, but I wanted to point it out to you that, hey, okay, I made it, and I imported it into the machine like I would any other piece of programming. Okay, so now let's get into our PET, or the source code. When I edit it, you'll recognize this from the previous episode. There's our jaw, there's our material. We're all set and ready to go. So the AOT is divided into 2 separate pages. I have a process sheet, and there are no processes right now, but F1 says machining section sheet. So when I hit that, it's showing me the individual machining sections, a section defined as a feature that we're going to make. And of course, there are none of them yet because I haven't done anything. So I'm going to reach down to F2 and I'm going to push new and edit, and it wants to know, are we doing turning or multiple machining live tool work? So we're just going to do turning for this episode, so boom, there we go. Now what it's wanting me to do from this machining section is define the shape of the part. So I could get up here and I could put in points, okay, and have it defined for me, but you notice right there, F2 DXF file read. So when I initialize that, it automatically opened up my AD0 where it is assuming that my DXF is located. Yep, there it is. I could have also put it in my MD1, but we did AD0 just to keep them away from our part programs. So I'll highlight that DXF and touch the word OK. It opens up the DXF, and son of a gun, there's my entire part. Now if I had multiple features on here, I could have them on independent layers, and I could turn off independent layers that I don't want to import for turning. Let's say, for instance, if I had holes in here and I didn't want the turning feature to think that was a feature that it could reach. But in this case, I just made a 2D DXF of the turning features. So when I hit confirm shape, it takes a look at everything and confirms that it is something it knows how to make. If it was not, if there was a flaw in my DXF, it would have told me there, but everything came out good, so I'll say okay. There, now it imported my part, and look at this. It saved me from doing all of this work. I could have keyed in all of that information step by step by step, but because I had a DXF, I don't have to. Now that I'm done, I'm just going to say okay, and now it has brought the material in, the shape in, it's all set and ready to go. Okay, great. So now what? There's my shape overlaid over my material, everything looks good. So now I'm just going to touch the magic button down here called Process Decide. This is the feature recognition software, And so it's asking me, hey, on my first spindle, what do I want to do? Do I want to do a specific tool to do everything? Do I want to designate certain machining sections? How do I want to do things? Like, do I want to rough first and then finish longitudinally? And if there's anything on my process sheet, do I want to delete what's there and replace it with what I'm about to decide? Same thing for the subspindle. Now we'll play with those in a little bit, but I just want to get this part done. So I'm going to touch the word execute, and the machine thinks about it for a second. Look at that. It just programmed everything for me, 100% of the turning. It's going to start by drilling through, then rough the face, rough the OD, rough the ID. Hey, wow, isn't that cool? Let's see how well Advanced One Touch did. I'm going to kick back over to my process sheet here. There's my entire program, and I can now do a process test just to see how well it did. Remember this? Yeah, there's my drilling. There's my facing move. Now we're going to finish the face and start roughing the OD. Looks good. Rough out the ID. And now we finish the face and the OD and do a finish on the ID. Now we're going to switch over to the second spindle. I just clicked on two spindle on this side, so now we can see that this facing cut is taking small steps based on the preferences that I set in the first installment in this series. And then the finish face. Look at that. With a couple of quick steps, I was able to program the entire part. Now, in theory, I could be done now, but let's take a few seconds since we're only 7 minutes in and yeah, we got good attention span. Let's talk about all these processes that the software kicked out. Let's say, for instance, that rough OD face, I don't like the preferences that the machine kicked out, 30 thousandths depth of cut. I can increase that simply by clicking into the depth field and modifying it, or I could touch process edit and it will open up that individual process. And now I could say, you know what, yeah, let's bump down our cutting speed or modify our feed. I could modify the shape if I wanted to. I could add or subtract tool indexing, approach positions. I could add an intermediate point where the tool will escape. These are all what we set in episode 1, but if I wanted to, I could override them here and, okay, customize this program to be exactly what I want. I also have the ability to edit this sheet and move things around. So let's say, for instance, that I have a saw cut on my blank and I don't want this drill to come into this rough saw cut face. So I would rather rough the OD face first. So I'm going to tell it, hey, that drill, I'm going to exchange that with the OD face. Bonk, and now I just modified those two. Isn't that cool? So now if I did my process test, we're going to see on the one spindle start that now it's going to face first. Yeah, well, I'll have to fix that. But then it's going to drill. All right, that's cool. Well, as long as we're here, Charlie, let's go ahead and fix that OD face by saying, yep, okay, next cut condition, next shape. There, my facing move only went down to X 0.5769, a little greater than half an inch. So I could edit that puppy dog if I chose and say, no, I want you to go all the way to X 0, or a negative if I've got a big, like a 32 thousandths nose radius. Now let's do the process test, same thing, and start. There he goes, all the way across the face. So we can modify and edit the program to our heart's content. Now, some of you that are a little sharper than, well, I am today, will look up here at my program and say, okay, yeah, there are 6 evolutions, 6 processes for the main spindle, 2 for the sub spindle. I think I see something missing. There's no transfer in there. Oh, dude, well, let's do a transfer. Since this is a slug, we don't have a part off routine to go in with this. Makes it super simple on us, but we're going to talk about it when we get there. I'm just going to highlight the next available blank, and we're going to do a process edit. This is how we could manually insert a process into our program here. Now, don't worry that it's at the end of the program right now. We're going to be able to modify that here in just a second. But this is going to be on the first spindle, and in my selection of what kind of process I'm working on, I've got options. That one right there. And see that? See that little icon? That looks like what I want to do. So I'm going to click on option, and son of a gun, there's a part transfer right there. Left to right, right to left. Yep, we're going from left to right. And now I just have to add a few pieces of information like, are we doing a reverse transfer? No. Are we doing a torque skip? Now this is a great little Okuma feature where when the subspindle comes in, if you've got blind jaws that can bottom out on the part, it will come in and find the face of the part and apply a certain amount of torque in order to make sure that we're holding the part tightly and the repeatability is great. It will continue to hold that torque while the jaws clamp, and then it'll release the torque and will escape. So we're going to say, yeah, go ahead and give me the torque skip. Do I have a cutoff process? If I did, I would already have that defined, and I would touch cutoff select and indicate which of my processes is the cutoff. In my case, yep, I don't have a cutoff process. Torque limit 1, 2, and 3. That is the overall torque. That is the amount of torque to be applied while I'm moving in, and the third torque value is the amount of W-axis torque that it's going to apply on the part while it's clamping. This allows me to induce a dwell into the program as the jaws are opening and closing. It's not really necessary because if I have my sensors on the chuck, clamp, and unclamp set properly, then I don't need a dwell, but I'm going to leave it there. Now, transfer start point. This is where I'm going to rapid tube before starting to come in. So let's just say I'm going to go to 1 inch. My transfer point, I have set my W0 so that the base of the jaws are touching the material at W0. So I'm going to say that's where my transfer point occurs. My transfer feed rate, let's do 50 inches a minute. And my escape, where do you want to send the W2 once we're done? Let's give it 100 inches. That's greater than the travel of the W, so that means it's going to park that axis all the way home. Now I have an approach and an intermediate point. If the torque skip does not sense the part within a certain threshold, it will alarm out, meaning the part is too short. Little safety feature. Or if it senses torque too soon, it will alarm out saying the part is too big. So that's what these guys are going to do. I'm going to let it know when I'm approaching what is my tolerance. I usually do about 100 thousandths, and if I over travel by 100 thousandths, then I know I'm no good. Then my turret escape in X and Z, that's fine, I'll leave it alone. A chance to index the tool, put a certain tool in the cutting position, even though I'm not using it. if I've got big long tools sticking out, I don't want that tool to be in the cutting position when W-axis comes forward. So I could either say, yeah, I want you to put the previous tool in position, I want the next tool in position, or hey, I'm going to designate a tool, and in this case, let's just use tool number 1 because that'll be the turning tool. Should be fairly short. Now I'll touch OK, and I've got a transfer all programmed. Now, unfortunately, right now it's at the end of the program, but no big deal. We know how to do it. Sheet edit. We're going to exchange that with that. Bonk. There we go. So now I have all my main spindle work, a transfer, a finish OD face, and a rough OD face. Why is that backwards? Haha. Let's exchange those guys. Exchange with that guy. There we go. That's a little more like it. Now when I'm done, I'll just say quit on the machining sheet edit and continue on. Same main spindle, sub spindle. Hey, awesome sauce. So now we've got a little idea of how to modify these, but we're going to make you stick around for episode 5 when we're going to go in here and we're going to create some processes step by step so that we can get a full understanding of what all those pages were that I just kind of breezed through. So I hope that helps you out. Hope to get to see you on episode 5, which should be dropping here pretty shortly. I do have some crazy work in the field these days, but I'll get on it as soon as I possibly can. Hope to see you out there.